G'day everybody, where's Wally here? Well, we have all heard Mitchell, from Australia, bang on about sextants only working on a flat Earth, and that they cannot work on a globe.
Since January 1, 2020, the globe has been dead. So now it's time to prove where we actually live. May I present to you the #1 flat Earth proof.
Well, at the end of this video, I have yet another one of my fantastic challenges for Mitchell. My money is pretty safe though. He's gone shy when it comes to doing my challenges. He hasn't even touched the $50 show a line from the SCP to the GP of the SCP. It's a super simple challenge, but oh well, his loss. But first I want to show why Mitch is in a ditch when it comes to sextants and navigation.
And flat earthers have just been looking for that one thing that we can put our finger on.
Yeah, you lot have been struggling for years to come up with an actual proof that can't be debunked in less time than it takes for a Tesla to go from 0 to 60.
That one thing that when people say, what would you say is the #1 flat earth? Well, this is it. The sextant celestial navigation. We stand here before you, anchors dropped. We're dropping anchor on the sextant, on the #1 flat earth proof. The way you use the premise behind why the sextant works.
Are you sure you want to tie yourself to that anchor, Mitchell? Oh well, having done that, can you just stand up here on this plank for me? Now take a short walk, will ya?
The #1 flat earth proof. And you can tell, it's very telling how polarizing this is for the globe believers, because nobody is addressing it. And when they do start to address it, they beg the question that they're already on a globe.
It's not begging the question if you assume a starting position and declare it, that could be either a globe or flat, and having picked one, then you do your test, and if it doesn't match reality, then it's likely you picked wrong. But as you see on this diagram, globe works fine. Must be right.
You just need to know how the sextant works. It has a flat baseline from the observer eye through the sextant to the horizon. If you can't achieve that flat baseline, a straight line, the 0 point where you're going to measure angles from, then the sextant will not work. It is as simple as that. If there is no flat baseline, you cannot get an angle. This is an angle measuring device. That's what the sextant is.
Yes, it's an angle measuring device, and it absolutely does not have to be from a flat baseline. It can measure from any reference point to another reference point, like a star, like Polaris or Sigma Antarctic, or it can measure from vertical or from a horizontal surface of, say, a liquid of mercury or a bowl of water. It's not hard.
But 100% of the time, they need to be measuring an angle. And that can only occur if you have a flat baseline to begin with. That's the killer blow right here. That's what we're measuring.
Straw man much, Mitch? Seems you don't know sextants, Mitchell. You can absolutely measure any angle between two separated points.
It needs a flat baseline from the observer's eye to the horizon, and then we can measure angles from that. The flat baseline. And we know from the black swan that that horizon there, that's not Earth curve. It's not a tangent line on a sphere. If you're thinking it is a tangent line on a sphere,
Tell me, Mitch, why can't it be a straight tangent line? Mathematically, a tangent to a sphere is totally acceptable. Oh, you need to remove tangents from play, don't you? Sorry, bud. Tangents work because maths says so.
It only works on the globe.
I think we can agree. We're all on a massive high right now from proving that this is the #1 flat earth proof. That's what we can stand behind. That's what we can hold up and say. We can physically measure the earth is flat. This is #1 flat earth proof.
Can you, though? Have you actually tried to measure the Earth using the sextant? I have a challenge for you at the end of this video. See if you're able to put your skills to the test and get the right answer.
When you're viewing a star on a globe, how are we measuring an angle to the horizon? That line, 90 degrees above your head, the zenith, actually runs to the center of your spherical Earth. And 90 degrees from that, the celestial horizon is a horizontal plane passing through the Earth's center, perpendicular to the zenith. So, you can now use your sextant. So yet another horizon is needed. They use the bubble level in the sextant to create the artificial horizon, is parallel to the celestial horizon. Because even globe believers know you cannot measure an angle to a curved surface you think's beneath your feet. Look at this.
This is a good one. 90 degrees right there. and obviously all the parallel rays are forming different angles there.
So now they can actually start and take a measurement from their 0 point of the artificial horizon to the celestial body. Look at what the globe believers are doing. They then have to measure from the artificial horizon a dip angle down to the visual horizon, the only actual horizon that we have. Do you all realise now how devastating the black swan actually is to the globe?
Okay, seems Mitchell is right across how sextants on the globe actually work. Good boy, Mitchell. Who's a good boy?
This is how we have proven our flat earth, Wally. Please go to my video titled The Number One Flat Earth Proof on my channel. It's got about 10,000 views at the moment, Wally, and do a debunk of that.
Oh, Mitchell, I hate to break it to you. I don't think you're the number one flat earth proof anymore, mate. I actually found someone who is really number one flat earth proof. I say this because he actually makes more sense than you do, Mitch. Here, let's have a look.
To see that picture there, look, he's zenith, standing there in the centre of his arc of horizon. 5k.
Yeah, that's
horizon.
right, Clive. It might be in the
Overhead.
test.
Zenith, you're always zenith. No matter where you are on the earth, the zenith. Don't believe me? Go to Stellarium or understand celestial navigation. That's what happens.
Celestial.
You use the almanacs. You take your sextant reading, you get an angle from the horizon up to a star.
Oh,
The
celestial.
book wants to know where you are in relation to that star
Yeah.
and your zenith. So whatever makes up the angle to 90 degrees, then you are zenith. Then the book does a calculation, the distance there, and tells you exactly how far you are from that star's GP point down onto the ocean. Now they've got to figure out those GP points. Oh, it's all mathematical, but they've known it for millions of years. Already, it's all
Millions
math.
of years.
All math. So there you go.
So let's have a look at his so-called number one flat earth proof, shall we?
May I present to you the number one flat earth proof. Here in reality, we live on a flat plane.
Well, I skipped a little bit here, but whoa, stop right there, Mitchell. You assumed flat, and according to you, assumptions are no-nos.
Yeah, I was wrong. And this may be news to people. We also have a flat sky plane.
Whoa, stop right there, Mitchell, again. You assumed the flat sky plane, and according to you, that is a no-no. And also, it's totally unproven. A double no-no. Strike two, Mitchell. Not a good start.
Yeah, I was wrong. Above us, where the celestial bodies exist. From the vantage point of our flat plane, when viewing the celestial bodies, we perceive their position and movement as a dome.
Yeah, to make your navigation work, you have to curve the unproven sky plane, don't you? That's strike three, Mitchell.
This is purely our perception from this vantage point on our flat plane. It's not actually a dome above the Earth. All celestial bodies rise in the east, move in an apparent semicircular motion above the sky, and set in the west.
All celestial bodies? Really, Mitchell? Are you sure you want to make that positive claim? Let me show you. No, actually, ask your kids to show you the SCP one more time. Those celestial bodies rotate around the SCP. They don't move from east to west. In fact, the stars between the SCP and the GP of the SCP are observed to be moving the other way. Sorry that these facts are inconvenient for you, mate. That is strike four.
Now don't get me wrong, our Earth is measurably, observably, and obviously contained. But it just doesn't have to be a dome shape, or any shape for that matter. But I digress.
Saying I digress does not make you sound intelligent. On the contrary, it makes you sound exactly like Quantum Eraser.
Looking at this flat celestial plane above our heads, we can see that everything rises in the east, moves across the sky, and sets in the west. We just perceive a motion of a dome shape. Every star in the flat celestial plane has a position relative to our flat plane where it will be 90 degrees. This is called the geographical position, or the GP, of that star relative to our flat plane here on Earth. When the observer is at the GP of the star, it appears 90 degrees above their head. Celestial navigation works by using a sextant to measure the angle of that known star and using its relative GP, geographical position, to know where you are. And I'll continue to point out that measuring angles to celestial bodies only works if we are on a flat plane.
Oh my, Mitchell, do you see the problem you have here? Who am I kidding? Of course you don't. Okay, if you're going to claim that you can calculate D by using the angle of the star, then you're going to need H for that. And Mitchell, you most definitely do not have H.
All those stars we have to treat all those stars as if they were the same elevation. But they're obviously not a physical elevation. You cannot do trigonometry to get distances.
Wow, I have not seen that much hand-waving since the last royal visit. Such an amazing fail, Mitchell. Here you are saying you can't use triangles for triangulation and you're showing triangles on the screen. My goodness. So you went and had a problem with me having a curved line between 2 points on the triangle, and you said, whoops, that's not allowed. But the problem you got there, mate, is it actually is, because I was actually stating the distance between the 2 points. I was not worried about the shape of the line at all. It can be unicorn shaped for all I care. Doesn't matter. It's actually the distance between the points that matters. I'd say get Kiwi to explain this to you. Of course, from his spot up on top of Mount Stupid, he's not going to really have any chance of helping you, is he? Sorry to kill your year of the sextant, but Mitchell, you're wrong. 10th Man is wrong, Nathan is wrong, and Kiwi, as always, is totally wrong. Let me show you why you're going to need H. The only thing you know is the GP and the angle to the star. However, D is proportional to H for any given angle. Triangles say so. Here in my little diagram, 3 different H's give you 3 different values for D, and triangulation is not possible when you have ambiguous circles of possible position. Basically, you have an infinite number of circles, you have an infinite number of possible positions from one sighting and an infinite number from the other, so now you've got infinity squared. That's bigger than infinity, or is it? Hell, I don't know. Anyway, Mitch, I know that's strike 5, and you're out.
We can conclude that they are both on what's called a circle of equal altitude. And this is another killer blow to the globe right here. Everything on that circle of equal altitude is exactly that, equal altitude. No matter where you are on that circle, you're going to measure 30 degrees. And through being able to measure an angle to that star relative to the horizon, everything on that circle, in between that circle, in the area of that circle, is absolutely flat.
Killer blow, you say, Mitch? Well, more of a wet tissue, if you ask me. See, mate, you have not proven that the area inside the circle of equal altitude is flat. On a globe, the circle of the Tropic of Cancer is a circle of equal altitude to Polaris. But inside that circle is a chunk of the planet that isn't flat. It's a huge-ass curve.
You called, Wall?
No, not now, Hugh.
Oh.
So every single time you say the area inside the circle of equal altitude is flat, that is only on a flat Earth. Here, in reality, it's curved. So that point of yours kind of proves absolutely nothing. Well, except that flat Earth is really desperate.
By doing this once with a sextant, you know you are somewhere on that circle of equal altitude. To triangulate your actual position, you need to repeat these steps with other stars. Your position is where all these areas of equal altitude meet.
Oh, well, that's strike 6, because on a flat plane, each circle is ambiguous, so you cannot define a point. Ambiguous circles crossing ambiguous circles means you still got no idea where the hell you are. Let's double check to see if Mitch is in a ditch much. We'll have a look at from another video. This is Flat Earth School number 28.
And this is what we get from the sextant. We can use the sextant to measure an angle. This is the observer point here. We measure an angle to something like the sun. We'll call this the sun. We know this is the only radius value that we can distinguish. Yeah, the distance from the GP point of the celestial body like the sun, straight line down to the GP point. We know how far away we are using the sextant, using the angle. 3 straight lines here creates an area of equal altitude.
How exactly are you calculating R there, Mitchell? If you're going to calculate R, you're going to need H for that. You do not know how high that star is, do you? You're assuming the height.
Yeah, I was wrong, and I can admit I was wrong. This is not devastating for me at all. And when we use multiple areas of equal altitude, see the 3 parallel lines? Yeah, these stars up here. So if that's 3 different stars, their GPs are all parallel, meaning that not only is the Earth flat, the baseline that you need, the sky is also flat. Yeah?
Flat sky? How do you know this? Again, then you're going to need H for that.
All those stars we have to treat all those stars as if they were the same elevation.
Oh wow, you just debunked your celestial navigation entirely there. You're assuming H, but you still need to know what H is, otherwise you can't calculate your distance, or R.
Yeah, I was wrong, and I can admit I was wrong. This is not devastating for me at all.
So Mitchell, here we come to the challenge. I want you to prove that you can measure a distance using the sextant on a flat plane. Here is what I want you to do. What you're going to need is a drone and that theodolite app like you've been using just here. That'll be just fine. I think you'll need a clipboard and a marking pen and a large flat area like a field or a sports ground. Okay Mitchell, are you ready? Starting at one side of the field. Fly your drone up high, hover it, lock it in position, maybe point the camera down to record this whole challenge too, and that would be nice. Now show the controller and its setting. Stand under the drone and show that it is at 90 degrees using your little theodolite app. Now walk away, count the steps till you get to 80 degrees on the theodolite app to the drone. Walk away, count the steps to 70 degrees and write that down. Walk away to 60 degrees and write it down. Then 50 degrees and write that down. And then 40 and 30, and hopefully you're still on the paddock. That'll do. Okay, show the camera what you recorded. Excellent. Now fly the drone sideways or towards you a little bit, just some random amount. Now measure the angle to the drone. Show the camera. Now looking at your calibration you've just created, have your best guess at how many steps you will need to get back under the drone at an angle of 90 degrees. So basically, how many steps are you going to need to walk back to the GP of the drone? Say your guess out loud for those playing at home. Now walk to under the drone, counting the steps out loud as you go, so measure them out. If you get the right number to say within 5%, then $50 will be added to your Patreon. Do you think you can do that, Mitch? Now if you want to get the other $50, I want you to stand right under the drone again. You should already be there, so that should be easy. Now fly the drone away and also up or down a little bit. Show the controller as you do this so we can see you adjusting it. Now measure the angle to the drone. Have a look at your calibration and make your guess as you did before as to the distance and how many steps it's going to take you to get back to the new GP of the drone, right where the drone is at 90 degrees above your head. If you get the right number this time, to say within 5%, then another $50 will be added to your Patreon. So that is only $100 maximum, Mitchell. No sneaky business here, okay? Good boy. Let's see if Mitchell can fly away with any more of the Wolfpack Petty Cash. Thanks, guys. This is fun playing with my new chew toy.
You can tell, it's very telling how polarizing this is for the globe believers, because nobody is addressing this.
Well, you just made a claim there, Mitchell, and to say that nobody is addressing the flat Earth celestial navigation via the sextant failure Most people aren't really bothered with what you're saying, Mitchell, because, now what's the word I'm thinking of?
That's stupid.
Oh, thanks, Taboo. That's perfect. Well, you know what? Destroying Mitchell's sextant flat Earth theories has been a massive amount of fun, but you know me, I'm kind of a generous guy, so I really shouldn't have all of this fun by myself. Now, who could I ask to come along and give a little bit of a final wrap-up for me? I know, Mr. Sextant himself, Bob the Science Guy. That'll really grind their gears, won't it? Take it away, Bob. Give me a couple of minutes of break from this absolute mind-bending nonsense.
Let me explain to you briefly how a sextant works. It depends on two things. One is the curved surface of the Earth, and the other is parallel rays of light from the sun or another celestial object. To explain why it works like this, let's go to the whiteboard and explain 4 possibilities. The first possibility is going to be a flat Earth with a local sun. The second possibility is a flat Earth with a distant sun and light coming in parallel. Down here we have a curved Earth, or a globe Earth, with a local sun, and a globe Earth with a distant sun and light coming in parallel. Now, let's go see what we actually see on the Earth. First of all, let's look at this possibility, a flat Earth with a distant sun. Every single shadow would be equal. Now, the reason I have double lines on this is that indicates that the sun is coming straight down onto the stick. So if the sun was very distant and the light was parallel, if there was no shadow on this stick, there wouldn't be a shadow on either of these sticks. That's not something that we see on Earth, so that's not a possibility. Now let's look at the next possibility. How about a flat Earth with a local sun? Well, if this stick had no shadow, there would be a shadow on this stick and a shadow on that stick. And quite frankly, you could triangulate using the base distance to the stick with no shadow, because that's a 90-degree angle there, and you would come up with a fixed height of the sun. Now, Blue Marble Science, B-Ball for Life, and I all did the Eratosthenes experiment from different parts of the world. Now, while we were all able to successfully calculate our latitude, we all came back to different heights of the sun. So, this is not a possibility. Now, in case anybody missed it, we've just ruled out the possibility of a flat Earth with either a distant or a local sun. It's no longer a possibility. We're only dealing with a curved Earth. So the idea that a sextant proves the flat Earth is just ridiculous. So let's look at our 2 possibilities here. First of all, we have a local sun and a curved Earth. Once again, the sun is directly over this stick, so that would be the GP of the sun. There would be a predicted angle right there and a predicted angle right there that would give an altitude of the sun above that GP. We don't see that. Whenever we measure the angle to the sun from different locations on the Earth, we always come up with different altitudes of the sun if we try and triangulate it. It just doesn't work. So this isn't a possibility. All right, so we're only left with one possibility, and that's a curved Earth with a distant sun. Rather than just do that as a diagnosis of exclusion, so to say, let's go ahead and have a look at it. Now, in this situation, the sun is directly over this stick right here. That would be the GP. We would have predicted shadows at each of those 2 sticks. What's the prediction? Well, for every 60 miles away from the GP, that shadow would increase by 1 degree. And that's exactly what we see in real life. That's how we do navigation with a sextant. So once again, if you want to navigate with a sextant, you're going to need a globe for that. You're also going to need R for that. Fortunately, we have both. This is Bob the Science Guy. Thanks again, Wally, for having me by. Take care.
Well, Bob, as usual, that was absolutely fantastic. I could not have done that any better myself, and that absolutely exactly what I needed. Thanks for that, mate. So that's Bob the Science Guy, but he's at his other channel, Research Flat Moon, and I'm going to put a link up here. And look, if you guys have not subscribed to Bob yet, what's wrong with you? Get over there and click on his link and subscribe, because his channel absolutely rocking all of this stuff. And we just know that whatever he says, the flatties hang on every word and just hate on him even harder. So get over there and give him some subs and get that sub level up even higher, because we know the flatties hate to see that.
It's very telling how polarizing this is for the globe believers.
Well, it sure is polarizing, Mitch. Sorry about that, mate, because you're over there all by yourself with your little friends, but, well, I guess these guys over here kind of think what I'm thinking might make a lot of sense. Sorry about that, Mitchell.
Mitchell, you want to do celestial navigation with a sextant? You're going to need a globe for that. Luckily, I can help.
Hi, I'm Mr. Sensible, and I approve this message. Celestial navigation with a sextant? You're gonna need a globe for that. P.S. Mitch, when you are using a sextant for celestial navigation, you're not triangulating your position.
Hi, I'm Sean Hawkins, and I approve this message. Celestial navigation via a sextant? You're gonna need a globe for that.
Hi, I'm Critical Think from Down Under, and I approve this message. Celestial navigation with a sextant? You're gonna need a globe for that.
Yes, Flannel Walk. I am your father. Oh, it's recording.
Hi Wally, it's Wolfie6020. Sorry about that, I was just having a bit of fun. Celestial navigation with a sextant, you're going to need a globe for that. We have triple inertial reference systems, 2 aviation grade GPS receivers, 4 crew iPads on the flight deck, 2 Garmin GDL50s and a bad elf. It's dark and we're wearing sunglasses, but when all else fails, we have the ultimate backup, the sextant. And this never fails.
Hey Wally, thanks for having me stop by. You know, the bottom line is this. If you're going to use a sextant for navigation on Earth, you're going to need a globe for that. I'm Bob the Science Guy, and I approve this message.
Well, guys, I think we're just about done. Oh, one more thing for those of us who are lovers of irony. Sorry, just put your fingers in your ears for a few seconds. This is Nathan Oakley, and this is really funny.
You're making a claim that we're on a flat Earth.
Yeah, triangulation proves that you can only do this triangulation if the surface of Earth is flat. I've already stated that several times. Now you're talking about beach balls and begging the question of spheres. You still haven't acknowledged whether or not you understand what a begging the question fallacy is. Do you or don't you?
I absolutely do, and I believe
What's a begging the question fallacy?
I believe you're doing it.
I'm not doing anything. I'm talking about triangulation. That's facts. Not begging the question of anything. If you are triangulating, you will, fact, have a straight, flat baseline. That's not begging the question. That's a fact.
I told you you'd get a chuckle out of that. I just pop over to Nathan's and just let him know that I've made a little video that he might not be too happy about. Poor Nathan. Thanks, guys. Don't forget to do all that button clicking stuff down the bottom there too. You know, click, like, subscribe, tell your mum, all that stuff.